I got a fun question here about tangent lines. I'm going to just make up a problem. F of x equals minus 3x squared. I'm trying to follow the structure of what they wanted. You're supposed to find the slope of the tangent line. Well, sorry, the derivative at a. And then I think they provide an a value, like, let's make one up, 4. And you're supposed to use the sort of classic definition, f of a plus h minus f of a over h, the limit as h approaches 0. Right. So of course, plugging in 0 is a problem because you have f of a minus f of a over h. So we get 0 over 0. So I'm going to do this kind of the classical way, then I'll do it the shorthand way. Of course, the classical way is kind of the demonstrating your full understanding of limits. And then the shortcut way is, this is if you want to execute this problem and get it right, this is the easiest way to do it. So if I plug in a plus h into this function, I get minus 3 a plus h squared. If I plug in a into this function, I get minus, now I've got to keep track of my negatives here, minus 3 a squared. Okay, so this is going to be where the hard part is. I got to square this out, minus 3 a squared plus 2ah plus h squared plus 3a squared. And of course, the distribution here, minus 3a squared minus 6ah minus 3h squared plus 3a squared. That term is going to go away. All I'm doing right now is the numerator. Okay, so this whole section is just this top part. I'm simplifying this down. I get negative 6ah minus 3h squared. Okay, now I'm ready to put it over h. Minus 6ah minus 3h squared over h. We can factor out an h from the top. Negative 6a minus 3h times h, boom, boom. So now I have minus 6a minus 3h. And if I'm taking the limit as h approaches 0, then this term goes away. So the answer is minus 6a. So if a is 4, then I get negative 24. Now, in shorthand terms, when I take the derivative of a power, and I can't remember what sequence of things has happened and whether you've done it yet, but basically the power drops down, multiplies. So this is minus 6x is the derivative function for minus 3x squared. So at that point, then I can just plug in a into that. So one of the things that's critical about this problem is connecting a and x, right? I'm saying an input of a, so that's connecting to the x value. So there's a point 4 comma question mark. They don't give you this, so you have to know what this is, but you can just do that by plugging the regular number into the regular function. Negative 3 times 16 is negative 48. Negative 48. Okay, so this is the actual coordinate. This is negative 24 is the slope at that coordinate. And so I just need to put those two pieces of information together and I'll have my equation. Now they say equation generally, but they force you into using slope-intercept form, essentially, because they have y equals. So y equals mx plus b. I know that a point that works is 4, negative 48. So I'm going to stick that in. I'm going to stick the slope in. And now I'm ready to solve for B. So I think this is negative 96. Negative 48 equals negative 96 plus B. Add 96 to both sides. And we end up with 48 equals B. So the answer then would be y equals negative. This is the answer to the second question. What is the equation of the tangent line at that particular point? That's the equation. Now let's go ahead and check it in Desmos. So I got a couple things here. I got the minus 3x squared. I want to graph that. I got my line of my tangent, equation of my tangent, and I've got my point for negative 48. So I'm going to put those three things into Desmos, and we'll take a look and just make sure that that all makes sense. Pull Desmos up here. Share my screen. So first off, f of x equals negative 3x squared. And then secondly, I got the point 4, negative 48. Let's call it P. And then we'll put on y equals negative 24x plus 48. Okay, so first of all, the scale is not very good here. I'm gonna go change my scale a little bit. I don't need quite so much on the x, maybe negative 5 to 5. And then the y, negative 50 to, okay, looking good. Here we go. There's my point, right? For negative 48, there's my tangent line. You even get the visual of what the tangent line looks like. It's the slope at that point. Right, the line goes and it touches it at just one point. We zoom in, we can see the separation between there. It's only at this point that it touches and then it starts moving away again. So that's a visual of what the tangent line looks like. So again, from a kind of computational perspective with this type of problem, it's much easier to just use the power rule. I don't know if you've got the power rule. Of course, the question asks you to use the limit, and you ought to be able algebraically to do that limit. This is an especially easy one, the quadratic, and they get much harder with the square roots and the, sine and cosines, all gets way more complicated. So this is a pretty straightforward problem. The only difficult part in doing that computation is the a plus h squared, I think, where you have to make sure you're actually doing the binomial distribution right. So just to be clear about that one part, right? When you stick in a plus h squared, just got to remember that's a plus h times a plus h. So that's a squared plus ah plus ah plus h squared, which is a squared plus 2ah plus h squared. And it's a great example of where you've got some sort of underlying fundamental skills that ought to be strong. Whether or not they're strong really depends on your experience and memory and, how well you understood and, felt about things when you're going through college algebra and trig. But those things keep coming up in calculus, and I would view them as an opportunity to reflect and strengthen. Don't get mad at yourself for not remembering how to do something, but definitely draw your attention to it and say, like, okay, I don't remember how to do this. I need to practice this. I need to strengthen it. And if you need help kind of figuring out what that might look like, let me know. All right, I'll talk to you later.